In this section, we're going to talk about factoring quadratic trinomials again, but in this case, the coefficient of the squared term is not going to be 1, okay? So factoring trinomials whose leading coefficient is not 1, okay? Now recall, a quadratic trinomial is a trinomial of the form ax squared plus bx plus c. We know that a, b, and c can be any real number. They could be decimals, fractions, integers, okay? For the most part, we're going to be dealing with integers. Like I would say all of these are going to be integers. We do have the condition, though, that a cannot be 0. This x squared term is what makes this trinomial quadratic. We would say this is a second-degree polynomial because the degree of the polynomial is 2. If a is 0, that squared term just becomes 0 and it's no longer quadratic, it's linear, okay? So we do have to make sure that a is not 0. And in the previous section, a was very specifically 1, and we found a kind of a shortcut, a trick to factor in quadratic trinomials where a is 1. Well, now we have to figure out what in the world do we do if the coefficient of the square term is not 1 and it cannot be factored out. Okay, so I'm going to do one video for topics 1 and 2 because they're just review. We need to review a couple of features before we get into the actual factoring. So for topic 1, we're going to review the FOIL method. Now, we reviewed this in the last video, but I want to review it one more time. So remember, the FOIL method is used to multiply two binomials. So it just gives us a way to remember the order that we multiply our terms in. So FOIL stands for first terms, outer terms, inner terms, last terms. So if we had a plus b, that being our first binomial, times c plus d, the second binomial, the first terms would be the first term of each binomial. The outer terms would be the terms on the outside of this product, so A and D. The inner terms would be the two terms in the middle of this product, so B and C. And the last terms would be the last term in each binomial, which would be B and D. All right, so it just gives us an order in which we would multiply these terms, okay? Essentially what you're doing is you're taking each term in the first binomial and you're distributing it through the second binomial, and then you want to simplify if you can. So let's look at example 1. It says find each product, and then I have this extra piece that says, what do you notice when you multiply? Well, let's go ahead and multiply and see what we can figure out. So for part A, we would take 2x times x, that just becomes 2x squared. We would then take 2x times 4. Well, 2 times 4 is 8, and then we just keep the x, so we get 8x. We're done distributing 2x. We're going to come and get the 7 now. So I'm going to take 7 times x, which is 7x, and then 7 times 4 is 28. And then I want to see if I can combine these two terms, the 8x and the 7x. So I get 2x squared plus 15x plus 28. Now, what do we notice? Well, we notice a couple of things, hopefully. We have this 2 and this 28. If I take 2 times 28, I get 56. Okay, well, that's cool. What do we notice about this 8 and this 7? Well, if I take 7 times 8, I also get 56. But even more importantly, 7 plus 8 is 15. These are all going to become really important features when we start factoring. Okay, so we're going to do this thing called the AC method, where we look at the constant times the coefficient of the squared term, and we find factors of that number that add up to be the coefficient of the middle term. Okay, now let's look at part B. So part B, we're going to start with 3x. I get 3x times 2, 3x times 2x, sorry. So 3 times 2 is 6. X times x is x squared. I'm going to take 3x times 1. That's just going to be 3x. I'm done distributing 3x, so I'm going to go pick up the -5 and distribute that. So I get -5 times 2x. Well, -5 and 2 is -10, and then we just keep the x. And then I'm going to take -5 times 1. That's going to be -5. I want to combine like terms anytime I can. So I get 6x squared minus 7x minus 5. Well, what do we notice? If I take A and I take C, I get 6 times -5, which is -30. And then notice here, this 3 and this -10, when I multiply those, I also get -30. But more importantly, when I take 3 plus -10, I get -7. So again, this AC method allows us to take A times C, so the coefficient of the squared term times the constant, find factors of that product that add up to be the sum of the middle term. So what we're doing when we factor these trinomials is we're starting here and then we want to end here. So remember, the whole idea behind factoring is you're rewriting a polynomial as a product. So we're just going to basically reverse engineer the FOIL method, okay? That's the first thing we need to review. The second thing that's going to come up in this method is factor by grouping. So we talked about this a couple of worksheets ago. So this is used when you have a polynomial with 4 terms that you need to factor. So the steps that we need to take, if necessary, you need to group the terms so that each pair of terms, so you basically split the polynomial in half, but you want to be able to split it to where the first 2 terms have a common monomial GCF and the second 2 terms have a common monomial GCF. So sometimes you have to rearrange the terms, not too frequently, but every once in a while you may have to rearrange terms, so that can happen. Once you do that, you factor each half of the polynomial. And then what that causes is it causes the entire polynomial to have a binomial GCF that you can then factor out. Okay, so let's look at this. So what I want to do is I want to kind of split, just imaginarily split this polynomial in half. Okay, now looking at the first 2 terms, the 2 on the left, I have x squared plus 4x. Well, the left GCF, let me actually do that in black so you can see it better. The left GCF is just going to be x. That's the only thing these 2 terms have in common. So I'm going to write my GCF and then a set of parentheses. Inside the parentheses, I'm going to put the quotient from where I divide out the GCF. So I divide both of these terms by the GCF, which is x. For the first term, I have x squared divided by x. That's just a simple quotient rule. So we keep the base of x, and then we subtract the exponents. 2 minus 1 is just 1, so I'm going to write that as just plain old x. And then I have 4x divided by x. Well, x divided by itself is 1. 1 times 4 is 4. So I just get x times x plus 4. And if I were to distribute here, I would get right back where I started with x squared plus 4x. Now looking at the second 2 terms, the right GCF, notice the lead term on the second or the right-hand side of this polynomial is negative. And remember, if the lead term is negative, that's the term with the highest degree. If the lead term is negative, the GCF needs to be negative. So I need to factor out negative something, okay? Well, these 2 terms only have a 7 in common. So 7 is a factor of negative 7x. 7 is also a factor of negative 28. So I'm going to make my GCF negative 7. So I'm going to write, I've got my x times x plus 4, and then I'm going to write minus 7, since my GCF is negative, and then a set of parentheses for my quotient. And then we divide both of these terms by negative 7. Well, negative 7 divided by negative 7 is just 1, leaving that 1x, so plain old x. And then negative 28 divided by negative 7 is 4. So what has happened here, and hopefully you can see this, but if not, what's happened is now the left and the right-hand side have an overall GCF. So the big GCF here is this binomial x plus 4. So we have 2 terms. The first term is x times x plus 4. The second term is negative 7 times x plus 4. Those 2 terms have an x plus 4 in common. So we're going to take our GCF, x plus 4. We're going to divide it out. So I'm going to write my GCF times a set of parentheses for my quotient. And then I'm going to divide both terms by x plus 4. Well, x plus 4 divided by itself on the left is just 1. 1 times x is x. And then x plus 4 divided by itself on the right is just 1. 1 times negative 7 is negative 7. So that is factor by grouping. If I were to FOIL these 2 binomials, I would get, as long as I didn't simplify, I would get what I started with. Okay, so FOIL and don't simplify and you'll get what you started with. Let's look at this second one. So let me go green again. So we're going to, again, just kind of split this imaginarily down the middle. All right. Now, looking at the left-hand side, so the left GCF, well, the left 2 terms have an x in common. Okay, both terms have at least one x. And then both terms have a 2 in common, so the GCF on the left is 2x. So I'm going to write my 2x and then a set of parentheses. Then I divide each term by the GCF. Well, 2x squared divided by 2x, 2 divided by 2 is just 1. X squared divided by x is just a quotient rule, so we keep the base. And we subtract the exponents. 2 minus 1 is just 1. I write that as just plain old x. Now, negative 10x divided by 2x. Negative 10 divided by 2 is negative 5. And then hopefully you can see that x divided by x is just 1. So we're left with just 1 times negative 5. All right. For the right-hand side, those two terms have just a 3 in common. So the GCF for the right is going to be 3. But because it's positive, I'm going to write plus 3. Make sure you put the plus or the minus in between these two sides. And then a set of parentheses. I divide by 3. Well, 3x divided by 3. 3 divided by 3 is 1. 1 times x is x. And then negative 15 divided by 3 is negative 5. So once again, hopefully you can see that by factoring each side of this, we're left with one big GCF. So we've got two terms here. The first term is 2x times x minus 5, plus the second term is 3 times x minus 5. So the big GCF here is x minus 5. So I'm going to write my GCF. Oops. And then I'm going to leave a set of parentheses for whatever's left when I divide. I divide both sides by x minus 5. Well, on the left, x minus 5 divided by itself is 1. 1 times 2x is 2x. On the right, x minus 5 divided by itself is 1. 1 times 3 is 3. And we have just factored by grouping, okay? This is going to be an important part of the process that we're going to use to FOIL these quadratic trinomials, okay? So make sure you have practiced the FOIL method and you kind of understand where all these numbers are coming from, and then make sure you have also taken some time to practice factor by grouping.